Chapter 2, Section 2.1, represent relations and functions. It says a relation is a mapping or pairing of input values with output values. The set of input values is domain. The set of output values is the range. Some other words you may know for the domain and input would be, again, here's input, could be the independent, or for the output could be the dependent. Also, just plain old X and Y. So they give you a relation here with some points. So they give you the ordered pairs. You can see them also on a table. You can graph them. There may not be a relationship between each of these points, but you can still do the X and Y coordinates. And then a mapping diagram, which we'll talk about shortly in more detail, has the inputs tied to some outputs. Okay. All right, so example 1. Consider the relation given by the ordered pairs listed here. Identify the domain and range. So, well, the domain are all the X values. So that's the first number, of course. So, I love my abbreviation. So D for domain. -2, it's just a list. -1, 1, 2, and 3. And yeah, ideally they should be in order as far as from smallest to largest. Not that important here. The range is going to be the Y values, so -3, 1, 3, -2, and 1. So looking at that second list, there are 2 numbers that are repeated, so you would not count the 2 1s. It'd just be one of them. Hence, it's best to just have them in order. That way, those fall out. So now they want, we listed the domain, we listed the range. Oh, well, they should have gone over here, I guess. Part B, they want you to map it out. So we can just put the coordinate points on our little map here. So it's -2, -3. Pretty simple stuff. -1, 1. 1, 3, 2, -2, and 3, 1. And the mapping diagram of the inputs and outputs, I'll put them in order here for us. So we start with -2. In fact, these were in order up here. -2, -1, 1, 2, and 3. The outputs, going to put them in order as well. -3, -2, 1, and 3. Now mapping is actually pointing from input to output. So -2 went to -3. -1 went to 1. 1 goes to 3. And 2 goes to -2. And last, 3 goes to 1. That's the mapping. Now, let's delve further into these. Functions. A function is a relation for which each input has exactly one output. If any input of a relation has more than one output, the relation is not a function. So one input to one output. But there's some tricky things about that. Let's look at the first one. Inputs on the left, outputs on the right. Looking at each input, is there only one output for it? Well, -3 only gets you 2. That's good. -1 only gets you 3. Perfect. -2 only and ever gets you -4. And 4 gets you -4. Well, each one of these only gets you one output. So that's good. That's a function. Look at the second one. -2 gets me -4. Okay, it's good so far. Let's go down to number 4. 4 gets you 3. That's good. But look at number 1. Sometimes 1 gets you a -1. Sometimes 1 gets you a 2. This right here is not a function. You must have just one output. For example, think of a factory. Now, here's your little factory. Get a little smokestack. You're putting stuff into the factory. So for each thing that comes into the factory, only one thing can come out. So anytime for this relation here, you put a -2 into the factory, okay, it comes -2, it always spits out a -4. Good. You put a 4 in, it always gives you a 3 out. Still good. Now the factory puts in a 1. Uh-oh. Now it's spitting out, some days it spits out a -1, sometimes it's a, what is that, 2. Well, this is not consistent. You know, whatever comes in needs to have the same thing out. And because 1 gets you these 2 different outputs, not a function. Vertical line test. A relation is a function if and only if no vertical line intersects the graph of the relation at more than one point. Essentially, you're just going to take a pencil, straight edge, and as you go along the function that's drawn, it should only cross that function once. And on this first example, you have this little parabola here, and the curve going up. It only ever touches it once. On the figure on the right, as you go across, when it touches here once at 0, as you go across to the right, increasing numbers, you're crossing at 2 places. So this is not going to be a function. All right, equations with 2 variables. Many functions can be described by an equation in 2 variables, such as y equals 3x minus 5. The input variable, in this case x, is called the independent variable. The output variable, in this case y, is called the dependent variable, because its value depends on the value of the input variable. So turn over to example 4. Graph the equation y equals -2x minus 1. Well, again, just some shortcuts to this, for these linear functions. We'll get to those later. But for now, let's just do it by x inputs and y outputs. Let's put these x inputs into the equation and see what we get for the output. A lot of times for tables, the input's usually on top if you have a horizontal table. If you like the vertical tables, usually the input's on the left. So it's something to look forward to when you're unsure, something that don't always label what these are. Anyway, putting these values in, -2 times -2 is +4. 4 minus 1 is a 3. -1 times -2 is 2. 2 minus 1. 0 just becomes 0, -1. And you can see the pattern hopefully developing. So the next one should be a -3. 1 times -2 is -2, minus 1 is -3. And I'm quite certain the next number is -5. Let's go graph this. So these are just these are 5 pairs of points. And -2, 3, 1, 2, 3, -1, 1, 0, -1, 1, -3, and 2, -5. And there's your equation of 2 variables. Example 5, classify and evaluate functions. Tell whether the function's linear. Then evaluate the function when x is -4. Well, first of all, a couple things. Anytime you see these blanks like this could be a negative in here, subtraction. All right, linear, you guys have been through this with Algebra 1 and even in geometry. Linear is always going to be x to the first power. So this would be a linear equation here. This is linear. A example, x squared. In fact, I think this is a -x squared because it's getting a space before the x squared. The x squared changes the graph. We'll talk about these in a few chapters. That is nonlinear. Okay. And then they say evaluate the function when x is -4. So we'll do that for both. So -4 in here, -4 times 5 is -20. -20 plus 8 is, so when g is -4, it is going to be, what is it, -8 and -12. On the first one, putting a -4 in for the x squared, you square the -4 first, so it's going to be 16. This becomes a -16. -16 plus 8, because -4 times 2 is -8, plus 7 is -1. So f, 1, -4 equals, what did I say, 1 or -1? I think I said -1. All right. Now for the example, please do the guided practice on your own, and we'll show you the answers in class. Okay. You can graph this one. I think you can graph it up here anyway. And you can tell whether your functions or not. For the guided practice, you guys can do these on your own. and we'll show you the answers in class.